Hello, everyone. This is Fu Pan Li from Ant Group. I'm from from China, and this is my first time to Korea, and so I have nothing to do with Korean, so I have to give this speech in English. Now first, I will give an introduction about myself. I'm the Kata containers maintainer in the Kata community, and I also maintained the Kata containers cluster in Ant Group. Maybe you have heard Alipay. Yeah, Alipay is one of the Ant Group's product, and maybe Ant Group has run the world's largest Kata container cluster in the world. Today's topic, I will talk about Kata containers meet the service mesh. First, I will talk about the agenda for this topic. First, I will give some simple introduction about what is Kata containers. Second, I will give a simple introduction about what is service mesh and where service mesh is so popular today. And third, I will talk about the Kata containers security threat model and where the service mesh sidecar mode will give some issues to Kata containers and how we fix these issues. First, I will talk about the latest service mesh trend, the sidecar-less service mesh, and how this mode is combined with the latest Kata containers. And last but not least, I will give a live demo about today's topic. Now, first, what is Kata containers? Before I talk about what is Kata container, let's introduce the traditional container, RunC container. As we all know, the RunC container will use the Linux kernel's some virtualization infrastructure to isolate the issues, such as the namespace, IP namespace, and PID namespace, and some cgroup mechanisms to confront the resources the containers used. But sometimes we all know all of the containers in the RunC container will share the same kernel. They share the same kernel and the same resources in the system. So sometimes maybe one malicious container will escape its namespace or some namespace confine, and they will isolate or they will influence with each other. Maybe they will break and give some dangerous to the other containers running on the same host. So we will use the VM isolation to fix these issues. The Kata containers use the VM to isolate the containers. As you know, the Kubernetes uses the pod name to run an application. So for Kata containers, we move the pod containers in one VM. And the containers in the VM will not easily to escape from the VM. Thus, the containers can't influence with each other on this host. Kata containers also compatible with the Kubernetes community, and it's a very popular runtime in the Kubernetes. And you can deploy it with Kubernetes plus Containerd and run your service. And that's I said in my topic, this is for Kata containers 4.0. So Kata container has evolved from Kata containers 1.0 to 2 and 3. We launched the 3 last year with the new architecture. And now, Kata containers can support multiple hypervisors from the traditional hypervisor queuing and to the latest cloud hypervisor and even the AWS Firecracker. And in the Kata 0.3, we supported a new hypervisor, Dragon Ball, which was launched by Alibaba Cloud. Talk about Kata containers. Let's talk about what is service mesh. Now, what is service mesh? Where we will use the service mesh? As we know, before the service mesh appears, we write the traditional applications. We will deal with most of the network issues, such as how to find the service and how to retry the failure connection, and we will encryption or decryption some data. And those functions and those functions always will be involved in the application codes. So in order to fix some issues this model bring out, we traditionally put all this network logic into a SDK library. But the SDK library also have some issues because first, the SDK library is language specific. If you support multiple languages, you have to write most of the language SDKs, and you have to maintain a lot of these SDKs. And if there are some issues in the SDK, you have to fix it, and then you have to recompile your programs and redeploy them. So the SDK mode has some issues. Thus, the service mesh appeared. What is service mesh? The service mesh is put the SDK's functions into a separated sidecar, and thus the programs will split out with the service mesh function, and the service mesh can be deployed separately, and the programs can be language incompatible. They don't have to worry about what the language it used. You can use Python, Java, Go, extra languages to write your languages, write your programs, and you don't care. You don't have to care about the service mesh functions, since the service mesh is deployed in a sidecar, and it can be deployed separately. So the sidecar, what will sidecar will trigger some issues? How the sidecar treat issues to the Kata containers? Yes, we can see that if we put the service mesh sidecar as a sidecar in Kata containers, the sidecar will be cooperated with the application container in the VM. As we all know, the service mesh sidecar will contain some key or some certifications. This is a private keys, and they shouldn't be accessed by some malicious programs. But if we put the service mesh and the application all together in the guest, so it has the same issues with the traditional RunC containers, because the traditional RunC containers isolation is maybe so easy to break out. So if there's one malicious container will break out the namespace, and they will stolen the private keys or some certifications from the service mesh sidecar. So I think for Kata containers, it should move the service mesh sidecar out from the Kata containers VM. Yes, this is the what we want. We move the service mesh sidecar out the sandbox so that even if there are some malicious application in the guest, they will not easily break out the VM boundaries. Thus, the service mesh sidecar is very safe. So if we moved the service mesh sidecar out of the VM, how do the service mesh sidecar to communicate with the application container? Before we move the service mesh sidecar out of the VM, they both in the VM, they will communicate with each other from the network stack. Yeah, the service mesh, we all know the service mesh use the RP tables rules to hijack the data flows, data in the guest. Thus, if we moved them out of the VM, how did the sidecar to hijack those network data? And how we make them exchange the data between the application and the service mesh? Yes, we found there's an existing implementation which we called about the TSR. This TSR can fix these issues. The TSR is a new project developed by the LabKRAM project. If you want to know much more about TSR, you can access its GitHub website. How TSR is worked? TSR is a new mechanism. It will hijack the traditional socket operation, such as the new socket or bind address or listen, accept, etc. Those system calls. It will hijack these system calls and translate these operations into a VSOC socket operation. And then he will try to translate those commands, such as bind address or connector address. Those will through the what.io, VSOC what.io command and put them into the hypervisor VM side. And the VM side will catch those commands and they will do those socket operations to support the TSR. Thus, a traditional application, they don't have to change anything. They will compatible with this TSR mechanism. They will call the traditional system calls just as they do, and they think they use the Unix socket or even the AFNet socket, but actually the socket operation has been translated into the VSOC operation. And the data communicate between the application and the service sidecar will use the VSOC. Yes, the VSOC is the virtual socket, which there is no network static. There's no RP, no TCP or TCP this stack, this cost. So it will exchange the data directly. So is that the end of story? Of course, no. So as I talked before, the service mesh has evolved from the service library mode to the sidecar mode? And what about the latest service mesh trend? Yes, the service mesh community has found the sidecar issues, and they have tried to make a new mode for the service mesh. Yes, this is a sidecar-less service mesh. Because the sidecar service mesh mode, you have to deploy one sidecar to cooperate with one pod. If you have 100 or even billions or thousands pods in one node, you have to deploy the 100 and even 1,000 sidecars in your host. This is very resource cost because even your service is very simple or very easy, very simple footprint. You have to deploy a footprint service mesh sidecar, such as Envoy. Now, the mainstream service mesh community has evolved two separated sidecarless service mesh. One is Cilium service mesh, and the other is H2 ambient service mesh. The Cilium service mesh is different from the H2 service mesh. Cilium service mesh depends on the eBPF in the kernel. And the H2 service mesh, they use the traditional IP tables to hijack the data. So if we use the Cilium sidecarless service mesh, the Kata will be compatible with this mode. Just as I talked earlier, if Kata uses the TSI to hijack the application's data, and the service data will directly to input the VM side, and the VM side will send the data from the network stack. So if the Cilium service mesh uses the eBPF to hijack this data, also it can hijack the TSI socket data. Since the VM has on the host and the data is from the VM sent use the traditional socket, and the traditional socket will send the data to the host kernel network stack, and the eBPF can hijack them. So the Cilium sidecarless service mesh can work compatible with the Kata containers if we use the TSI service. How about the H2 ambient mesh on Kata? As we know, the H2 ambient mesh will split the sidecar into two parts. One is the tunnel, and the other is the waypoint. The tunnel is on the node. There's only one tunnel dim set on the node, and there is no much more sidecars. There's only one tunnel dim set on one node. So all of the pods have to communicate or send data to the tunnel, and the tunnel will send this data out. If we use the TSI mode for Kata containers and work with the tunnel, the data flow have to through the guest kernel and into the VM, and the VM will send the data to the host kernel net stack, and the host net stack, the data will pass from the host net stack and will be hijacked by the tunnel's IP tables, and it will redirect them to the tunnel. So for this case, the data will flow multiple parts. One is the guest, and there is VM and the host kernel, and reached the tunnel. But this will make the data flow much slowly and will improve the request latency. How do we improve these issues? So since the tunnel has worked on the node and the Kata containers has used the TSR, if we make the Kata containers VM to directly exchange the data with the tunnel, use the vhost user protocols, they will exchange the data directly in the user space. And the application data will not reach the host kernel's network static. So the data will exchange between the tunnel and the Kata containers directly. There's no much more data path to walk through. And this will make the data change very easily and make it much more less resource. Since it will use much less the CPU resource and also make the data change very fluently. So let's give me the summary. Kata containers has wanted to move the sidecar of the guest to meet its threat model. And the service mesh also have evolved from the SDK mode to the sidecar, and at the end, they will towards the sidecar-less. So those trends very match each other directly. And this makes the Kata containers to work compatible with the latest service mesh. And for TSI mode, Kata container, we have completed the codes by now. And next, I will give a live demo for this. And for Kata container to support with vhost user TSI, we have cooperated with Intel's service mesh team to work on. And I think will be completed by about November. So I will give a live demo. Also, here in my machine, I have a Kubernetes cluster, and we have a service YAML deployment. And this service can be split into two parts. And the first is a service definition. And this service will work on the port 8888. And the second part is a port definition. And this port is an Nginx server. And this Nginx server will use the Kata container runtime. And also, we have injected the ASTO Kata service mesh for this port. So let's launch this. Okay, we have launched this service. And you can see that this service has produced an Nginx server to running. Now we can list how many containers in this port. Yes, we have two containers in this port. One is Nginx server, and the other is S2 sidecar, S2 proxy. We can Yes, in one of them. First into the sidecar. Yes, we have in the sidecar. We can see that there's a network interface in the sidecar, and we can see its kernel is this one. Let's into the Nginx container. We can see that the Nginx container, there are only one local network. There's no other network in this Nginx server. And we can see its kernel. Yeah, its kernel is this one, and it's different from the sidecar. This means that those two containers also in one pod, but they are run in different machines. One is in guest, and the other one is in the host. And let's deploy another test pod. We call it Nginx client. Here we can see another pod has been running. And oops. Also, let me list its containers in this pod. Yeah, there's also two containers in this pod. One is the Nginx client, and the other is the H2 service mesh sidecar. So let's also into yeah, we have exec into the Nginx client. We can see that there's no network in these containers, but we can access the Nginx server from here. Before we access, we have to get the service IP address. Okay. We access it from the service IP address and its port. Yes, you can see that we can access the Nginx server successfully. So this is use the TSR since even there oops. Since there's no network in these containers, but we can also access the Nginx server because we use the TSI. The TSI will hijack the socket and we translate from the vsock. So actually, we access the server use the vsock instead of the traditional socket. Okay, that's end of the topic. Thank you very much.